Now, what I'm doing is I'm finishing up the last of my collectors for the Stephen Mark toroidal power unit. I'm using 36 gauge magnet wire. It comes off of here, goes through this little hole or eyelet. I just twisted that out with some aluminum. Then it goes across here to my Litz winding machine that I built. I actually made this out of paint stir sticks that I got from a local hardware store, got them for free, and extended it out. In my original video, I had all of my bolts and everything else along the edge here, but it turned out that those were far too short for the Stephen Mark TPU. So what then I did is, working with some other fellows on this, on the internet at overunity.com, I went ahead and I lengthened it so I could have some long pieces of homemade Litz, and then also now I'm making some shorter pieces for the collector. Each one is going to be tuned both electrically and mechanically. We're tuning the resonance based on the speed of sound in copper and tuning it to particular frequencies, and I'll be getting into that more in the future. This particular winding, all of the windings for each collector, we're using 208 strands, and that'll give us about 12,000 feet of wire on the innermost part of the collector segments that'll actually be picking up the magnetic fields. That gives us an additional 12,000 feet of wire for the intermodulation that'll produce the harmonics that we're going to be needing. So it's pretty amazing. And because we're not winding actual coils per se, but lengths of wire that are in parallel, because it's going to be cut right here, then what you actually end up with is the same mathematical formula for resistors in parallel, is wire in parallel, so your resistance drops. So we're going to have approximately a total of 24,000 feet inside of the Stephen Mark TPU of this 36 gauge magnet wire at next to no resistance, which will make for a very high Q quality factor, as well as on the collector side, the pickup side, we'll be producing some tremendous power based on those rotating magnetic fields with very little resistance. In other words, we won't be losing a lot of power to heat. So pretty exciting stuff. Over here is my little count tool. I'm at 190 turns. I'm going to 208 turns on this Litz jig. Then this jig will be done here in my cluttered lab. I'll be able to make some room. I want to show you briefly, I've got my resonant cavity, basically my form, which is tuned based on its dimension and height to a particular frequency as well. And I'll be getting into that in the days ahead. We have on my thread, on my blog there at overunity.com, Bruce's TPU theory, version 1.2, under solid state. We have all the calculators and frequencies and everything else. So if anybody wants to join in the build with us. One of my partners is working diligently on the electronics. Another partner in Australia is working diligently on building the identical same thing wound clockwise. Mine is all going to be wound counterclockwise. So then what I'm going to do is, in my next little video, is take this, put it through some shrink tubing for you, and show you how I do that, and then shrink it down. That's about it for this. It's not hard. It is tedious, and I've had to make a total of 6 of them, and I've got those right here. And then, like I said, these still need to be tuned by cutting to the particular frequency, and that is done by the calculation of the speed of sound in copper to get to the frequency as far as mechanical resonance that we want, and we already know what we're tuning to. And so we have discovered or rediscovered Stephen Mark's secret, which all the credit certainly goes to that man. Without him, we'd be still in the dark ages. But a new power source, which is the Schumann's resonance, and how to tap into it using basically a lot of small pieces of parallel wire and using 3 frequencies that intermodulate harmonics And using aluminum wire for our control coils, they'll be tuned to a mechanical resonance as well. As we tune to a beat frequency that is close to, but not exactly at the Schumann's. If you get exactly at the Schumann's, it will destroy itself. And then we're going to have the geometric mean between that base frequency and between the diameter frequency. The geometric mean becomes our input frequency, where there are two carrier frequencies, which will produce hundreds of replicas of the harmonics. So I'll be going over all that in detail in the future, but this is really just to kind of show you the Litz jig, and it's the last collector I'm having to wind. Now, the reason I didn't buy Litz wires, Litz wire comes where it is already twisted, and twisted Litz is twisted to reduce intermodulation, and we're actually trying to produce and doing everything we can to encourage intermodulation. So we needed straight pieces, and so without spending a fortune, we were able to make our own. It is very tedious. Once we get a prototype going, we'll get a wire manufacturer and get whatever size wire we need to be made just like this as far as some Litz is concerned. So anyway, that's about it. Thank you very much.